Okay, so here's topic 4. So guys, this is 4 out of 5. We are nearly done the lecturing part of our unit. When you guys come back from our 4 days off, then we're going to start doing some case studies, some activities. We're going to do a research project. So we're going to do most of those tasks after I finish talking to you guys. So today I want to talk about air quality. This is a picture right here, and similar to yesterday's notes where I had 2 different bodies of water, and I kind of asked you, which lake would you rather swim in? I don't think I need to ask this question either. Do you feel like this city right here, do you feel like that's healthy air quality? Probably not. Nope. You can probably just look at it and tell, wow, that looks bad. Now, that being said, looks are not everything. There are more things to consider than just whether it looks bad, okay? The air quality could look fantastic, and it could be, it's perfectly clear, that's safe. But like, there could be things in our air that you can't see. Okay? I want to show you a picture here. Does anybody know where this is? This is Calgary, actually. And this photo was taken either this summer or last summer. And if you guys were around during the summertime, you know how we had like a lot of forest fires in the area, like Waterton gets shut down and you can't have campfire bans? This was Calgary one day, and someone took a photo 2 consecutive days, or like, the same shot. And like, wow, isn't that horrible? Just how bad, like, this is from the smoke of the forest fires is right here. Isn't that incredible? And I think most people, they know that on a day like this, keep your kids inside, don't go outside, like this is bad air to breathe. But the point I want to make as I begin my lesson again is that although the air looks really good on this day as well, we can't see everything. Does that make sense? So, but visual is a good place to start. Okay. Here are the 2 main ways I need you guys to know about how we measure air quality. Okay. Way number 1. We calculate the level of pollutants in the atmosphere. Okay? We actually go out and we do tests. Okay? And on a day like this, they actually have like a scale for air quality. Now, I don't actually know how the air scale works, but like there's actually a way of measuring it. You can say like that it's a 10 today. That's a bad day, whereas it's a 1 another day. Okay? So we can actually test the level of the pollutants and go out and measure them. There's a second way we can try to figure out air quality, but this one's a little less specific. We're going to estimate the amount of emissions coming from pollution sources. Imagine you have a big factory, and that factory is clearly polluting into the air. Okay? What we could do is we could just figure out how much pollution is coming out of the factory stacks and try to estimate how many emissions there are. This is a little bit trickier to do because we don't know exactly how far they're going to spread out. Ideally, it's going to start spreading out and dispersing. Do you guys remember that word, dispersion, from a previous set of notes? That's how things are going to get carried in all different directions. And ideally, slowly over time, it would dilute and it would become less and less. But it really just depends on how much the source is giving. Okay? Here's my last note on this slide. The amount of chemicals found in the air, we typically like to record them over many years to figure out long-term trends. The classic example is like carbon dioxide. We're going to talk about that later today. But what you'd do is on one axis, you'd put time. And on this axis, how much carbon dioxide you'd have. And unfortunately, as we plot these things, it often looks something like this. This is good? Probably not, because we're starting off with very little, and as time goes along, it's getting higher and higher and higher. And if carbon dioxide is not good for the environment, then this is a problem. Right? Ideally, maybe it goes up a little bit, and then it goes down and up and down, and it kind of stays like fairly consistent. That would be good. But if we ever see a trend where it's going upwards and it's some sort of pollutant that ruins our environment, our atmosphere, then yeah, we've got problems. So here's the first thing I need you guys to know. I would record this down. This strikes me as another really good test question. I need you guys to know what is naturally found in our air. Okay? Because there are chemicals naturally found in our air just normally. Okay? So let's use this picture right here to begin with. Most of our atmosphere is nitrogen, N2 gas. That's actually pretty normal. I even showed you guys on a slide in our very first set of notes something called the nitrogen cycle, where nitrogen gets used. There was a picture of a cow on that slide. You guys remember that slide at all? Where we talked about how nitrogen gets consumed in by plants and then it dies and decays as well. Nitrogen is a very large part of our atmosphere. The other large part of our atmosphere is oxygen gas. Why is oxygen so relevant to us? We need it to breathe and live, right? We require oxygen. Okay. But after that, then there's a lot of other things. Okay. For example, argon gas and then trace gases. These ones are so small that if I were to make a pie chart out of it, you can hardly even see them on the pie chart. So this right here is a second pie chart of just this little sliver right here. So these are all extremely tiny proportions of the 0.1%. But here's some other gases in our atmosphere. Carbon dioxide is a big one, CO2. And we're going to do some discussion on this today as well as in a project, but carbon emissions are a big thing nowadays. If you haven't heard this before, like a lot of different provinces have a carbon tax. Have you ever heard that word before, carbon tax? Basically, the idea is that if you're a polluter who puts carbon dioxide into the atmosphere, then there's a tax trying to prevent us from doing that because, you know, the graph that I drew back here, we are discovering that we're putting more carbon dioxide into the atmosphere, and it's causing global warming. We want to try to stop that. So although some carbon dioxide is natural, this number seems to be on the increase. Okay. Here's some other compounds: neon, helium, methane, nitrous oxide, and ozone. These are other common gases, but there's more than just that. There's also gases like sulfur dioxide, SO2, nitrous dioxide, NO2. And these are also pollutants, and these are pollutants that actually they can cause acid rain. We talked about acid rain a couple times before. So there are many different gases that we end up in our atmosphere, some of which are normal, and some of which are pollutants. Over the next few slides, I want to discuss basically a little bit about them. So let's actually discuss one of the first ones I mentioned there, sulfur dioxide. Sulfur dioxide is SO2. You guys hopefully are more familiar with how to name these things. Sulfur, S, oxide, oxygen, but the di means two of them, yeah. This is why we had to do chemistry first, right? So that we know how to name these things. Sulfur dioxide is a pollutant which causes both smog and acid rain, and it really affects your breathing system and your eyes. Okay. And so this is often caused by burning fossil fuels like coal, oil, natural gas. Any sort of power plant that burns something for energy is probably going to release sulfur dioxide. And here is like an equation of how sulfur dioxide can cause some problems. You guys can actually like read the chemical equation out. Sulfur dioxide reacts with water and limestone and oxygen, and it can form this compound here called gypsum and some carbon dioxide. And this makes things problematic because carbon dioxide is one of those things that causes global warming and climate change. And so we don't want to put sulfur dioxide into our air because not only does it reduce the amount of oxygen we have, but it increases the amount of carbon dioxide there is. So this is actually, I take this back, this is actually the equation for how we try to reduce sulfur dioxide from our atmosphere. Power plants are supposed to have something called a scrubber. That's a word I need you guys to know. And I mean, it probably just makes logical sense. What is a scrubber supposed to do? It's supposed to scrub the sulfur dioxide out of the power plant so that you're not basically sending so much smog into the atmosphere. Gail. Yeah, so I mean, you weren't here for the last couple of days, but our quizzes are going to be a lot of terminology, okay? I feel like most of this stuff, like you guys probably know, fossil fuels are bad. But like most of what you need to know now is the terminology for it. So I need you to know that sulfur dioxide is one of the major pollutants coming from fossil fuels, and we use a scrubber to try to get rid of it. Okay, here's another one. Nitrogen oxides. There are two common nitrogen oxides. One is nitrogen monoxide, which is NO. No. And then there's nitrogen dioxide, which is NO2. And these often come out of like cars. They come from the combustion of car like exhaust. You know how you see this smog kind of coming out the back of your car? Some of that could be nitrogen dioxide or nitrogen oxide. And these are also pollutants. Okay. Now, the note I have on the bottom here is that all three of these things, sulfur dioxide on the previous slide, nitrogen monoxide and nitrogen dioxide, they're supposed to be monitored, especially around cities with industrial areas. What does an industrial area mean? It's where you'd find, like, say, factories or power plants, maybe businesses, but we're not talking like Walmart. We're talking like, you guys know on the north side of town how they're across from the Walmart, there's the big Frito-Lay chip factory? That might be a good example of something like that. That would be like, that's the industrial area of town, right? Not necessarily where you're going to go buy your groceries, but a lot of those places, they're going to give off emissions due to however it is that they're I don't know, manufacturing things. Okay? So these gases are meant to be monitored because they're pollutants. Okay? I found here this graph that kind of talks about how over time different gases have increased. Now, I didn't seem to include the legend for some reason, so I don't know which gas is which here. But I think you guys can probably figure out the trend is that over time, this is going up, this is going up, and this is going up. And it's pretty clear to us that, like, as humans are doing things like transportation in our vehicles or making more electricity, it's causing our pollution to basically to increase. We know this. They're all increasing. Okay. Here's another gas I need you guys to know about. It is carbon monoxide, CO. And carbon monoxide is often known as the silent killer because it does not produce any sort of smog. You can't smell it. You can't see it. And yet, if you die by carbon monoxide poisoning, you suffocate. And the reason why is that rather than you breathing in oxygen, which your body needs, you're breathing in carbon monoxide, and it binds to your blood and does some bad stuff, basically internally inside of your circulatory system. It prevents you from getting oxygen that you need. Yeah. Yeah. Exactly. Actually, that's why I put that on the slide. I'm glad you mentioned that here, right? That was meant to be a talking point. Does anybody have a carbon monoxide detector in their home, maybe? Good, yeah. Right? We've learned more about this now, especially if you have a wood-burning fireplace. If there's something in your house that might be causing something to burn, like a natural gas fireplace or a wood-burning fireplace, or maybe even you just have natural gas as how your stove works, it's really good to have these carbon monoxide detectors because, like, you can't smell it. We have a carbon monoxide detector in our camping trailer because our camping trailer runs off of propane tanks. And yeah, if propane starts to burn but it makes carbon monoxide, it can cause a problem. So that is another one of the gases that is a pollutant. Okay. Here's another gas that's in our atmosphere, which is kind of not a pollutant, but kind of is a pollutant. It is ozone. And maybe you've heard of ozone before. Earth has what's called the ozone layer. Maybe you've heard that phrase before, the ozone layer? Okay. Ozone is O3. We talked about this briefly in our chemistry unit. This is known as an allotrope. There are some chemicals that always come in different groupings. O3 is ozone. By the way, O2 is oxygen gas, which we use for breathing. It's basically just got a slight difference. That's breathing, by the way. If you have an O3, it's part of the ozone layer. If you have an O2, we breathe that stuff. Okay. Now, is ozone good? Yeah, actually, it's very good. I don't know if you guys know this already, but the ozone layer protects us from ultraviolet light. Where is ultraviolet light coming from? The sun, yeah. And if you are outside without sunscreen on, you can get a sunburn. Now, okay, maybe you don't necessarily mind getting a sunburn. Maybe you think you're going to get a tan. But if you get too much exposure to ultraviolet light, it can give you skin cancer. You guys ever heard that before? That's one of the reasons why you want to wear sunscreen, because it provides UV protection. Okay? You guys ever heard of like SPF 30 or SPF 50? That's basically how good your sunscreen is. It's trying to protect you from the ultraviolet rays from the sun, preventing you from getting skin cancer. Okay? Well, the ozone layer is actually something that helps filter out ultraviolet rays. And so having an ozone layer is actually really good if we're talking way up in the atmosphere. However, you guys can read this. On the ground, though, ozone is actually very dangerous. We don't want to breathe in ozone. Okay? So if you ever get ozone down here on the surface of the Earth, it's more of a problem. Okay? Here's some pictures that kind of illustrate what I was talking about there. These are different forms of UV, ultraviolet radiation, that the ozone layer filters out. You can see that there's all these different rays. There's actually 3 different types, by the way. There's A, B, and C, 3 different ranges of these. And the ozone layer filters out almost all of UVC and most of UVB. It actually doesn't protect against UVA, but that's why we wear sunscreen. Okay. So that's what the ozone layer is for. However, if we ever have what's called surface level ozone, where somehow that ozone ends up down here on the surface, it's harmful to us as humans. And I've got more slides on that in a second here. Okay. Atmospheric ozone, though, the good stuff, has actually been depleting for a number of years. There's been holes in our ozone layer. Now, I don't know whether you guys have heard this before, but, oh, you have a question there. Go ahead. I actually have a slide on that here. That's awesome. Cool. Yeah. We're going to talk about that right here, basically. Let me build up to this. Okay. Again, I don't know whether you guys really, as you grew up, this was a big thing that you heard about, but I grew up in the 90s, and this was like the biggest pollution thing ever. Basically, the idea was there's holes in our ozone layer. It's decaying. We are polluting our Earth. We need to stop. And so what people were doing is they were putting something called CFCs, which stands for chlorofluorocarbon. They were putting them into the atmosphere. And we didn't even know it was causing problems until we started recognizing, whoa, the ozone layer has got holes in it. Okay? These came from things like aerosols and refrigerants. Okay, pause for a second. Do you guys know what an aerosol is? Something that comes in a spray can. Okay? And in order to make it to go out and spray, they put in these chemicals called CFCs, which gave it like its spray ability. But as soon as it caused it to spray out in all directions, eventually they floated up in the atmosphere and they would eat away at the ozone layer, and we didn't know about that. Okay? The other thing were refrigerants. Okay? Refrigerants are like cooling systems. It's liquid that we find in, say, like an air conditioner. And if those ever get released into the atmosphere, they were also breaking down the ozone layer. And so there were actually holes in the ozone layer that looked like this. Here's a photo over time. Okay? This is what the ozone layer normally looks like in green. Green is good here. Okay? And then you can see that over time, as it went from here to here to here to here to here to here to here, it was getting worse, specifically worse right in this middle stage here. You see how that big blue section right there? That kind of implies that there was a big hole in the ozone layer. It was actually a really massive one above Antarctica. Okay. I don't know why it ended up forming there, but that's where it ended up forming. Okay. Now, like you mentioned, though, I actually put a slide on here. In 1987, something called the Montreal Protocol was agreed to. And basically, almost all of the countries in the world basically agreed, guys, we're going to stop polluting with chlorofluorocarbons. They said, we're going to phase them out. No one's going to use them anymore. And in the 90s, that was a big thing. People basically stopped using them. And the good news is, I found this on a NASA study, actually. Just like you said you found on, what was it, Instagram? Yeah. Is that scientists now seem to have proof that the ozone hole is actually starting to recover, which is good. It's nice to know that as humans, maybe we pollute, and we go, whoops, didn't know about that one, sorry, Earth. And then we decide to change, and that the Earth kind of can start fixing itself. Does that make sense? It's kind of good to know that we've had success on that, because there have been other times when everyone's gotten together and said, hey, we should stop polluting, and it hasn't worked quite so well. So anyways, that's ozone. Now, here I'm talking about the good ozone. Now I want to talk about ground level ozone. If you end up with ozone on the ground, though, it is just like carbon monoxide. It is colorless, it is odorless, and you don't actually necessarily know it's there. And here's the problem. It affects people with asthma, colds, or really anybody with breathing problems. Because what asthma does is it affects your lungs. Okay. So although ozone is good in the atmosphere, if ozone, say, is something that gets produced by like the smog in your car or the smog in the factory, and ozone gets produced down here, then it's actually very bad for us. Okay. One more thing. Ozone also has the ability to cause problems with our crops. So like our agriculture industry does not do well under ozone, and it even causes plastic to deteriorate, which maybe is good, because maybe we want to get rid of our plastic, but in general, yeah, ozone is a pollutant. So let me do a quick recap of what we've discussed. I need you guys to know all of these chemicals. So quick recap. First one was sulfur dioxide, SO2. It normally comes from factories or burning fossil fuels, and we try to remove it by scrubbers, but that doesn't always work. Sulfur dioxide is also one of the things that causes acid rain. Nitrogen oxides. These things come from like car exhaust and industrial areas. They also can cause acid rain, by the way. Very similar problems I mentioned here. They have similar problems to sulfur dioxide. So these guys also cause acid rain. Those are NO and NO2. Carbon monoxide, the silent killer. It causes breathing problems because you're going to suffocate. Your blood, if you breathe in carbon monoxide, cannot bind to oxygen properly, and you suffocate over time. So you should have carbon monoxide detectors, hopefully. And then ozone's the next one we've talked about. And there's a good ozone, but if it's on the surface of the earth like this, it's not healthy for you. It causes breathing problems. Okay, now for the controversial one, carbon dioxide. This one is really big nowadays in the news. I'm imagining you guys being in grade 9, you probably don't read the news a ton, but like if you do ever catch stuff about carbon taxes, it's a big thing in politics right now, trying to save the environment. And I don't want to come down on like being like political on an issue. That's not my goal here. Okay, I just want to try to explain to you guys how the science works. But carbon dioxide is highly controversial to some people, and here's why. To some people, it's not a pollutant because it is naturally present in the air. Carbon dioxide is actually normally found in our atmosphere. That is true. I don't think anyone argues that. The problem is that if we were to make a graph of carbon dioxide over time, although there is supposed to be some, over time, it's increasing, and we're getting more and more and more of it. And that seems to correspond to increases in temperatures and climate change. And so there seems to be a very strong link between carbon dioxide and global warming. Okay. So the goal in the last century is to try to impose things called carbon taxes, trying to make us not be such bad polluters. And I found this graph online that kind of talks about how this is, I think, is this the amount per year? Or is that cost per year? I can't see it. Dollars per year, is that right? Dollars per year on that side? Yeah, and this graph basically is talking about how different provinces, they're trying to increase the cost per family by including some sort of tax. You guys will notice Alberta actually has one of the highest ones in the country on gas, on heating your homes, and just other things. Okay. You guys aren't driving probably that much yet, but does anybody remember how a couple years back the gas prices kind of took a big dip? They went down to like 70 cents per liter, and they've slowly been increasing again, and gas is back up at about $1.20, $1.30 a liter. Okay. One of the reasons why is that there are a lot of taxes on our gasoline, trying to prevent people from driving their cars so much. I'm not sure how well that works, actually. I think we would just necessarily pay more, but it's the idea. Okay. Here's a graph I have that shows global CO2 emissions, and when you look at a graph like this, it looks bad. It looks really bad. Because like way back here, was there carbon dioxide in the atmosphere? Yeah, there was some. But like right about here in the year 1900, all of a sudden it has just skyrocketed. Let's talk about why. What changed around the year 1900? What was invented? The car, yeah. And that really changed things because now it meant that we were always burning fuel to get around places. Before the invention of the car, around the turn of the 20th century, which is about the year 1900, people had to bike or walk or maybe use like a horse and buggy, right? If you've heard the name before, Henry Ford, the guy who made the Ford Motor Company, right? That really changed everything as soon as vehicles happened, right? But more than that, although vehicles were polluters, now there were manufacturing industries making the cars. And that also was contributing more carbon dioxide gas to our atmosphere. Does that make sense? And so we often refer to this time as like the Industrial Revolution. Anyone ever heard that phrase before, the Industrial Revolution? Where now industry takes over and we have manufacturing goods. And yeah, long story short, there's been a big increase right here. Okay. The United States, China, and India are some of the biggest polluters we have in the world. I read a stat that says that Canada only gives about 1% or so, maybe 2% of the world's total carbon dioxide. Oh, really, most of the carbon dioxide emissions come from these big countries, the US, China, and India. And it kind of makes sense, though, because they're the biggest population countries in the world. Both India and China have over 1 billion people. Canada has about 37 million people. So, like, it's really not all that close. So, well, here's another graph. This is, again, CO2 emissions. Now, this is a little bit more recent. This is from 1965 to 2014. And it's, again, how much carbon dioxide there's been. Now, the good news is the developed world has more or less tapered off. Now, what do I mean by the developed world? This would be countries like the United States, Canada, Australia, Russia, Japan, and everybody in Europe. However, the developing world is places like China, India, a lot of countries in Africa. Their increase is getting higher and higher and higher. And one of the reasons why is that they're starting now to get things like industry and power plants and vehicles, and they didn't have them before. And so really, in a way, all of these countries here, they did their polluting before, and now it's kind of leveled off. These guys right here, India and China, they're only just getting going on their pollution. If that makes sense. So people are recognizing this as a problem. And so a few years ago, there was a thing called the Paris Climate Change Agreement, where basically all the countries in the world decided to get together again and say, guys, we got to stop putting carbon dioxide in the atmosphere. And they set some goals. Most of the goals were to reduce their emissions by the year 2030, which is a long ways away still. And so the goal basically was in 15 years for everybody to try to get their numbers for how much they're polluting carbon dioxide, try to drop them back down again. But the goal was not to do it by like 2020, it's to do it by 2030. And there's some people who are a little pessimistic about this because they say that that's just way too far in the future. And like, just like you guys, if you procrastinate and you say, I'll do my assignment later, sometimes that doesn't work so well. And there's some pessimists who think that if we say, we'll get there by 2030, that may not work all that well. So, okay, now let's talk a little bit more about carbon dioxide. Although it can be a pollutant, it's actually a vital part of photosynthesis. Do you guys remember talking about photosynthesis in our last unit? Photosynthesis is literally how plants grow. Plants need carbon dioxide, water, and light. And it makes sugars and oxygen. So plants actually need carbon dioxide. A certain amount is actually healthy. Too much, however, causes this. It causes it to be a greenhouse gas. You guys ever heard that word before, a greenhouse gas? If you haven't, let me give you an explanation. Okay? Basically, the idea behind a greenhouse gas is that they trap heat from the sun. Okay? You guys know how a greenhouse is meant to like grow plants inside of it? And one of the ways it does that is by kind of keep it warm all year round. Right? Like in Canada, plants don't usually do very good in December because like there's snow outside and they freeze. So a greenhouse is supposed to be like a nice warm place where plants can grow all the time. That's where the word greenhouse gas came from, because it's trapping heat. Okay. Let me talk to you about how it traps heat. Here's a picture here. The sun sends us heat, and most of that heat gets trapped by the Earth's atmosphere, and it kind of bounces around inside the Earth, and it stays with us, which is good, because if heat from the sun did not stay here, we would freeze. We'd be like Mars or Jupiter or Saturn, all of the other cold planets. However, some of the heat is supposed to like escape. It bounces off the Earth and basically leaves. What we've discovered, though, is that as we add more carbon dioxide in the atmosphere, as there's more of it, less of this heat right here is escaping. And it means that Earth is actually heating up a little bit too much. And we're noticing it slowly over time. It's only gradual right now, but the worry is that it's going to become worse and worse. Okay. Here's a picture that kind of illustrates some of the bad greenhouse gases. And I've already discussed a few of them. Ozone, water vapor is actually a greenhouse gas, actually. And so is carbon dioxide. Okay. And here's what happens in carbon dioxide, is that when sun that has a certain wavelength comes from the sun, this carbon dioxide right here, it traps more of it. Can you guys see how it says percent absorbed? What ends up happening is when you have too much carbon dioxide, it absorbs this wavelength of light from the sun, and basically too much gets kept. We want to keep a certain amount of heat, but we don't want to keep too much. Okay. Here is a graph that I found online that kind of is a prediction. Okay. This is what we're predicting is going to happen to temperatures, as well as what's going to happen to our carbon dioxide. Okay. Basically, the idea is that we're noticing that temperature is increasing right here. Okay. And we're worried that if it keeps going on this trajectory, if it keeps going higher and higher and higher, Earth is going to warm up between 3 to 5 degrees Celsius. Now, I got to be honest, guys. When it is minus 40 out and you tell me that we can make it warmer out, sometimes I'm okay with that. But most of the places in the world, an increase in temperature is not good. Okay? In Canada, maybe we'd be okay. But like Florida, in theory, could go underwater. That's a theory. Is that Florida is so low to the ground that water levels would rise. The ice caps would melt. And if ice melts, it causes the water levels to rise. There would be flooding. There's also predictions of things like disease or drought or even more violent storms. That's the prediction that climate scientists have for increasing our temperatures. And so if these temperatures continue to increase, that's what they're worried about. What they're hoping is going to happen is the blue graph instead. We're hoping that instead we can actually decrease our emissions and cool the Earth back down to kind of what it was back in the year 1900. That's kind of a benchmark year. They say that 1900 is the year we're going for because that's before the Industrial Revolution with cars and factories. Okay. But we're worried about it being right here. Here's that year again, 2030. They're hoping by 2030 that we start on the downward trajectory rather than the upwards trajectory. But I'm not really sure what's going to happen. You guys will be around to find out, though, because that's 12 years away. So. Okay, anyways, here's what I need you guys to know. Most scientists seem to agree on two things here. One, the Earth is getting warmer. That's what the evidence seems to tell us, is that global warming is happening. The question that some people debate, though, is to what extent is it getting warmer? Some people think that it's getting warmer just a little bit. Some are very worried. Some people are like, nah, I'm okay with it getting warmer. And others are like worried about exactly what could happen. You know, disease, drought, storms. They're their predictions there. Here's the other thing scientists seem to agree on. They do agree that human carbon dioxide emissions are a contributing factor. They're just not sure how much of a contributing factor it is. Okay? Basically what we do is we put two graphs side by side. And we say the graph of temperature, this is temperature, versus time is going up. But that seems to really correspond with the graph of carbon dioxide over time. There really seems to be an indication of a trend between those two things. Okay. However, there are some other factors to consider. I've got two last picture slides, then I'm done here. This is a slide I found that talks about how we believe we know global warming is existing. And there's a whole bunch of different things. For example, we know that there's more fossil fuel carbon in trees because we're burning more stuff in factories. Okay. We know that there's less oxygen in the air now because there's more carbon dioxide instead. We know that there's more heat returning back to Earth. Ideally, heat should be bouncing off the Earth, but more of it's staying. We know that the upper atmosphere is getting colder. We know that winter is warming faster than summer, right? And so there seems to be evidence that the Earth is getting warmer. The question is like, how bad is it going to get? Is it going to be like okay? Or is there going to be catastrophic problems? Okay. Here's my last slide. This is really a big debate. There are people who are like hardcore advocates either for climate change or there are people who are like, no, this is totally bogus. Okay? I'm not here to tell you which is which. I'm just trying to tell you what the science seems to indicate. There are some things that we believe are natural causes. Like, for example, the greenhouse effect. This basically is our carbon dioxide. Okay? That seems to be warming up the Earth. Okay? There's also things like, say, natural calamities. For example, anytime a volcano erupts, volcanoes spit all sorts of nasty gases into the environment. And those can actually change the climate. And that's kind of a natural thing. Can we stop volcanoes from erupting? No, those just happen on their own. Okay. Here's another one. Scientists believe that Earth's tilting axis is actually changing. Earth actually has a little bit of a tilt to it. There's actually a 22.5 tilt to Earth's axis. It's actually why we have our seasons. And we actually believe that's changing slowly over time, and that's causing it to become warmer or colder. But here are some things that we as humans are doing, and I don't think anyone can really disagree with some of them. Like, for example, increased automobile use. We drive more. You guys with me? Or are you busy making hand signals? Focus, I'm almost done, guys. Okay. Industrialization. We have lots more factories now. Okay. We do a lot of mining. And this is a small one, but we need to consider this. What is respiration? Breathing. Breathing. Now, let's talk about how we breathe. When we breathe in oxygen, but do you guys know what we breathe out again? Carbon dioxide. Now, in the year 1900, there were about 1 billion people on Earth. Do you guys know how many people are on Earth now? About 7, maybe getting closer to 8 billion, 7 billion or so. There are 7 times as many people on Earth, and everyone's breathing in the oxygen and out the carbon dioxide, and so that's another factor. Okay. The question then is, what can we do about it? That's really the question. Okay. Now, if I go back here, most scientists agree Earth is getting warmer, and we are polluting with carbon dioxide. Are there other reasons why the Earth is getting warmer? Probably. Not going to disagree with that. The question is, what can we do about it? Okay. I'm going to have you guys do a research project in part on this. That's actually part of what you're going to do for your research. So, Seabass. What was that? 6 meters? Yeah, in terms of like this thing right here, it would like almost all of Florida along the coastline would be underwater. Right? Basically, like all beaches, right? 6 meters would be like, well, I don't mean, it would be definitely higher than this roof. It's probably basically like from the ground floor up to here. We're probably 6 meters above the ground. Does that make sense? Right? So imagine that all the water levels rose 6 meters up. Like all the beaches, all the coastal areas, they'd be underwater. That's the prediction. Right? Will that happen? I don't know. I don't think anyone can know for sure, but that's what we're fearful of. So. Okay, let me summarize our day and then I'm done. I can give you guys half an hour to work here. I need you guys to know about some of the air pollutants. I covered most of them already in my review. Sulfur dioxide, nitrogen monoxide, carbon monoxide, and ozone are 5 I need you to know. The last one is carbon dioxide, and that one's always been a bit controversial because carbon dioxide is naturally occurring. We expect carbon dioxide in our atmosphere. The worry is, what if we have too much? We believe carbon dioxide is causing the greenhouse effect, where Earth is trapping too much heat and it's warming up. The question then is, what's that going to cause? Is it going to make it warmer in like a good way? Or could it cause other problems like flooding, disease, drought, storms? I don't know that anyone knows 100% for sure, but there are some advocates who strongly believe that we need to stop polluting our Earth right now, or like humanity is going to die out. There are some people who believe that. So, okay. Any questions? Okay, that's all I've got, guys. So you got half an hour. Can I give you guys some instructions? Then you can